Clarville C5, 1936. AK2H4000, 129D ABC1, AL2AZ1. This is the documentation of the experience of a hobby project, available in video and in written form, made with the hope that it could be helpful to others. But any comment that could help me to improve my practice is welcome and appreciated. The 13th Wireless Exhibition, or TSF, was held in Paris in 1936, in the Hall Citroën at the St. Lazare station. The list of exhibitors shows also the brand Clarville at the stand number 145. According to Doc TSF, the Clarville production was active between 1934 and 1968. The radio model of this restoration is the Clarville C5 that appears in the same advert promoting the brand at the 13th Wireless Exhibition, for which we know that this radio model must have been available in 1936. Otherwise, there is no other original information about it except for this other advert, probably from an independent seller, which in particular declares the intermediate frequency used by this model. However, the item under restoration does not have IF transformers with ferrite cores like this advert suggests. From Doc TSF it is possible to notice that there have been at least two series using slightly different sets of tubes, but also that this model was rebranded a BC radio. The item under restoration arrived fairly intact. However, the scale printed on the dial glass is almost completely dissolved. There is no back panel anymore, and the chassis appears covered with rust. The previous owner reported that before him this radio belonged to a friend of his who kept the radio for several decades in a barn in the countryside of central France. That explains the rust and the thick layer of dust. The oscillator mixer tube is missing, and it has been missing for a long time, judging by the amount of dust that accumulated inside the tube socket. Also, one of the pilot lights was harvested, probably for repairing another unit. The variable capacitor does not turn completely, and the external blades have been partly bent. Under the chassis, the components seem all original, with the exception of the electrolytic filter capacitor can, which however was not soldered properly to ground. The layout of components seems also a little bit intimidating for the presence of connections on the fly without a dedicated post for anchoring them. The radio includes a fusible wire hiding in the input voltage selector, which appears blown or just broken. Here is a first visual scan above and under the chassis. It may be interesting to observe that the power plug of this item was original. Only the power cord was replaced some time in the past. Before extracting the chassis from the cabinet, it is necessary to remove the knobs. For the purpose, some Vaseline oil is applied first on the corresponding set screws. Unfortunately, one knob is partly damaged. It will be repaired later. Also, the dial frame is removed. With the chassis extracted from the cabinet, it is possible to remove the dial glass, which is held in place by two springs, one of which was already extracted while removing the frame. The vacuum tubes are carefully removed, also applying Vaseline oil to the sockets and to the top caps in order to reduce the friction. All tubes, except for the IF amplifier, have a side contact base, known as transcontinental, which requires tilting them along a certain axis for inserting and extracting them from their sockets. Unfortunately, the rectifier is too close to the power transformer, and extracting the tube requires special care. To avoid raising a cloud of dust, for now a soft brush is used for some superficial cleaning. The original fuse is restored using some thin solder wire. As already mentioned in the previous section, the last repair that this item received was not very successful because the electrolytic capacitor can was not connected properly to ground. But also the connection of other components to ground was compromised, which may have been the reason for putting aside this radio. This radio model does not have documentation, apart from a couple of adverts. This also includes the lack of an original schematic diagram. Therefore, it is important to do some reverse engineering for this restoration project that starts from the RF coils. The letters used to label the terminals have been assigned arbitrarily. The inductances have been measured. The oscillator coil has on top two trimmer capacitors on a ceramic base. These trimmers are meant to be adjusted by rotating two nuts on threaded rods, which are part of regular screws inserted from the bottom of the ceramic base. Unfortunately, rotating these nuts, also the screws would turn because they are not held in their position. But the screws are inaccessible when the ceramic body is installed on the coil. In other words, under the circumstances, these trimmers would not be adjustable. The ceramic body with the two trimmer capacitors is separated from the oscillator coil. After cleaning the part, The original screws are replaced with new ones, but inserted in the opposite way, matched at the end with square nuts. The interval values of the two trimmers are measured, but at the moment this is not accurate yet, because they have just been cleaned, and they are not perfectly dry, which interferes with the reading. To keep the square nuts from turning while adjusting the corresponding trimmers on top, some hot glue is used. Hot glue is preferred in this case because it would be able to better stand the pressure applied on the screws while turning them, and because, if necessary, it could be undone just applying heat. The screws are extracted completely from their nuts and then reinserted to make sure that they have not been trapped by the hot glue. Then the capacity range of the trimmers is tested again. The ceramic trimmers are reinstalled on top of the oscillator coil, paying attention to respect the original orientation. Then they are connected using new wires and Teflon tubing for the insulation. In retrospect, also the original screws could have been used inserting them upside down and fixing the original nuts with the same hot glue. However, in this restoration, the IF transformers will need some important attention, and in that case it will be necessary to replace the trimmer screws. Therefore, changing also those used in the RF coil was the occasion to unify all the trimmer adjustments. Later, the shield cans of the antenna and oscillator coils are cleaned using fine steel wool and a metal polish product. With the hope of matching the color of the tubes, they will be painted gold, together with the IF transformer shields. At this point of the restoration process, there is already a draft of the reverse-engineered schematic diagram and of the map of the components under the chassis. However, the condition of the chassis requires the full dismantling, which is a process that takes quite some time because it must go together with the verification of the drafts that have been preliminary written. During this process, little corrections to the drafts are always necessary. These accelerated clips are meant to give the idea of how all this is done, and they are commented on only on some occasions. The band selector switch occupies a significant amount of space under the chassis, and it is located right on top of the oscillator mixer tube socket. Removing it brings the concerns of not being able later to reproduce the exact working condition of the oscillator or antenna sections. However, in this restoration, removal is a necessary major task. In this radio, the electrical contact to the chassis ground was provided by the factory using a thick copper wire, and no component was attached straight to the chassis. This choice contributed to a messy arrangement of parts that would not be reproduced while rebuilding the circuit, although every alteration in the way that components are connected raises concern of unknown different final performance of the item. The tube sockets and other phenolic parts were fixed on the chassis using rivets. These rivets are now removed using a wire cutter and a drill, paying attention to not damaging these parts. Unfortunately, the socket for the rectifier tube gets damaged. It will be later repaired because the body of these particular sockets is slightly thinner than the size of newer equivalents available nowadays that could not fit in the original holes in the chassis. Anyhow, it will work. Inside the radio there were some scribbles whose meaning is uncertain. These letters LRM were located near the antenna and pickup inputs. These annotations appeared on the shield of the second IEF transformer. They seem to indicate primary 30 and secondary 51. Finally, these annotations on the power transformer, but they don't seem to be intelligible. The chassis of this item is covered with a thick layer of rust, unlike in other projects, in which the chassis was submerged into acid for removing the rust and other signs of corrosion. This time a homemade rust remover gel is experimented. This type of experiment was never made before using commercial products because treating such a large surface would have been too expensive. It takes some effort, but eventually most of the rust is removed this way. However, some spots of corrosion do not want to surrender. Therefore, the usual acid bath is prepared. This time it is made of some leftover diluted vinegar already used before for another project with the addition of some muriatic acid. This was done outdoors and it lasted only 6 hours. Then the finally clean chassis was submerged into fresh water to get rid of all the acid residues. Finally, the chassis was dried and immediately sprayed with zinc paint for preventing the formation of new rust. The old wires soldered to the power transformer terminals are removed, together with the excesses of solder. Some superficial cleaning is done using an oven degreaser, and then the external shield is separated from the lamination core. The wires from the primary windings are connected to the input voltage selector, which at the moment does not allow to separate completely the shield. Therefore, it is necessary to remove first the small board that makes the input voltage selector so that it is possible to access and desolder those wires. The small board that makes the voltage selector is cleaned using various detergents including alcohol, but also the same gel substance that was used already for removing the rust on the chassis is used again now for polishing the contacts. The residues are then cleaned as well. Unfortunately, this small part is made of just cardboard, and the corners have been damaged while removing the rivets that held it to the metal shield. For repairing them, 4 small nylon washers are glued using superglue. Finally, it is possible to remove the metal shield, and the transformer laminates can be better cleaned. The original screws that kept together the laminates and the shield are type M4. An attempt is made to reuse them, but adding some insulation to prevent unwanted eddy currents. Unfortunately, the insulation tubing takes too much space, and with that the original screws would not be able to fit in the original holes. Therefore, new thinner threaded rods will be installed. With the transformer shield there is also a small frame which is installed on the other side of the laminates. Both these parts need to be cleaned, starting by removing the residues of the rivets. Then, the gel rust remover, already tested in this restoration project, is applied as many times as necessary to achieve an acceptable result. A wire brush is also used to help with stubborn rust stains. The wires coming out from the primary winding need some new insulation. Only the last taps will be used for 220 and 240 volts. Therefore, to avoid catastrophic mistakes, the other taps will be just completely insulated without connecting them to the input voltage selector. One wire from the voltage selector is supposed to be connected to an eyelet on the opposite side of the transformer. The transformer is tested without load, but also with a slightly lower input voltage, showing satisfactory output values. During this test, it is observed that the input taps for 220 and 240 volts are in fact only the same tap that is just duplicated. In other words, there would be no difference in selecting 220 or 240 volts. Before reinstalling the shield and the frame on the laminates, the transformer is masked for painting it. After painting, the transformer is reassembled, and the following clips should be self-explanatory. Time to take care of the variable capacitor. Off camera, the blades that were shorting have already been straightened. The homemade gel rust remover that has already been extensively experimented is used also on the variable capacitor. It takes a few applications before getting the final result, and every time the gel is washed away using water and dish soap. After the last wash, the variable capacitor is dried using an air blower. In the end, some Vaseline oil is applied to the variable capacitor on the bearings, but also on every surface and moving part that seems more vulnerable. This is the second IEF transformer, which is remarkable for the shielded connection that comes out from the top of the can, because it is directed to the plate of the IEF amplifier too. In other words, this connection brings B+, and it is important to remember that it should not be touched when the radio is powered. Moreover, the shield is insulated because the tube is an H4000 129D or RENS 1294, which has a conductive coat on the glass, which however is connected to the cathode and not to ground. Another thing to observe, but this is related to both IF transformers, is that the primary winding is on top, while it is more common to find it at the bottom. The connections of these IF transformers do not have numbered pins, therefore it is necessary to use wires with some color code to distinguish them, because the original colors are indistinguishable. This is the convention that will be used for this restoration. So here is the plan. The intermediate frequency transformers would be cleaned and the old wires replaced with new ones using appropriate colors. However, with these transformers, the process will become slightly more complicated. In the first IF transformer, this wire was cut inadvertently by the factory, leaving it in a condition of intermittent connection. This goes to the blue wire, which is connected to the plate of the oscillator mixer tube. One can imagine how many times this poor radio must have been tapped to make that intermittent connection work. The corresponding trimmer capacitor is electrically separated, so that it is possible to measure its value. However, some resistance is found instead, and it is unclear if that depends on the dirt accumulated with the years, or if that comes from residues of detergent just used for cleaning the part. Anyhow, it is necessary to inspect the insulation of the trimmer, but the nut on top used to adjust the capacity does not want to get loose. Then, it is necessary to completely remove the ceramic body of the trimmer pair, for trying to solve the issue without fear of damaging the coils. The screws corresponding to the nuts used for adjusting the capacity of the two trimmers have been soldered by the factory to some ground wire. In the meantime, the nut that was stuck has been able to move, but turning the screw underneath. Therefore the solder on the screw head has been removed, and now a screwdriver can be inserted. Still it does not work. Not finding a better option, a file is used to slowly consume the screw head. But before reaching the end of the screw head, the nut can suddenly be released. The parts composing these trimmers are more than expected. Unfortunately, they are dropped on the table without paying much attention. Luckily, there is also the second IF transformer, and the analysis of the content of the two trimmers can be done with care. On top there is the nut. Then there is a piece of metal used for pressing the trimmer blades underneath. Then there is a spring. Then there are 3 or 4 sheets of mica piled together. Then there is the upper blade. Finally, there is a thin sheet of mica and, at the bottom before the ceramic body, the lower blade. This complexity must have a purpose. Considering that for both trimmers the screws for the adjustment are grounded, this is the actual reverse engineered schematic diagram for these IF transformers. This type of arrangement guarantees that the adjustment screws or nuts are always connected to ground with no fear for shorts, also reducing the influence of the proximity of the tool used for the adjustment. After cleaning all the parts, the trimmers for the first IF transformer are rebuilt, but with new screws identical to those chosen for the oscillator coil inserted in the same way. However, this time, in place of the square nuts, 2 short brass spacers are used so that they could be easily soldered to the ground connection. Later, the same will be done to the trimmers of the second IF transformer for consistency. For extra precaution, also in this case hot glue is applied like for the oscillator coil trimmers. There is now a problem. With the measured values of inductances and capacitances of the IF transformers, there is no way to tune them to 460 kHz, which is supposed to be what this radio was designed for. The lower possible frequency could be around 600 kHz. It is also true that all these trimmers arrived completely squeezed down, which would demonstrate the struggle for reaching the lowest tunable intermediate frequency already at the factory. Therefore, the addition of capacitance in parallel to these trimmers will be needed, but it would be impossible to determine now what would be appropriate because the interval of values that the trimmers can achieve is too narrow. This obliges to prepare some extra contact under the IF transformers without shorting to the chassis, where these new additional capacitors could be installed, finding experimentally their right values. Wax from a teolite is applied to the coils for protecting them and for preventing them from unwinding. Like for the RF coils, also the IEF cans are cleaned using fine steel wool and a metal polish product. Also, these cans are going to be painted gold. With the cans painted, it is possible to put the IEF transformers back inside them. This is the example of the second IEF transformer, which has also the connection on top, directed to the plate of the IEF amplifier tube, therefore providing for that tube the B+. It is not shown in this clip. However, later the shielding coil will be soldered to the ground eyelet on top of the can. It will also be necessary to put proper insulation because the conductive coat on the tube glass envelope is connected to the cathode and not to ground. It is time to take care of small parts, starting from the tube socket and the knob that need to be repaired. Then, the excesses of solder residues are removed. For the purpose of cleaning the contacts, the sockets are soaked in the same gentle rust remover already used, but this time in its liquid version. After a little more than 1 hour, these delicate parts are extracted, washed with water and dish soap, and dried with an air blower. The same treatment is given to other small metal parts, but they stay soaking for a longer time, about 5 hours. Then they are washed and dried in the same way. The dial frame and the metal cap will be painted later, one gold, the other copper. The chassis has been prepared with zinc paint. A lot of ground points are made in advance, especially where it would be too difficult later because of space constraints. Most of these soldering points will not be used, but this abundance will allow more freedom in positioning the components. There is a plan to group some components on a board because the original arrangement included connections on the fly and a simple tag strip would not be sufficient. Therefore, the spacers for this board are also prepared. two solder points are in an inconvenient position. They are removed with the help of a wire cutter. The sockets are installed on the chassis, but instead of rivets, screws, and nylon washers are used. The Bakelite tube sockets are particularly delicate, and the nylon washers are necessary to prevent excessive tensions that would break them. This is the reverse-engineered schematic diagram of the unit under restoration. There are a few things to observe. First of all, the trimmer capacitors of the IF transformers do not operate exactly as it seems. Each one of them has an extra capacitance that goes to ground, and the screws or the nuts used for the adjustment are always connected to ground. These extra capacitances are added on the side of lower impedance. The tube type H4000 129D or RENS 1294 has a top cap connected to the anode, which means that it should not be touched. The same tube also has a shield on the glass made of a conductive paint. That shield is connected to the cathode, which means that it should not be shorted to ground. When the pickup input is selected, the oscillator mixer and the IF amplifier tubes are turned off by cutting their B+ line. There are two antenna inputs. One is decoupled by a capacitor, the other is connected straight to the antenna coils. One should be aware that connecting the antenna to the latter, if not properly isolated, could expose the coils to DC currents with the risk of damaging them. This is particularly important if the antenna is located outdoors, where even without being hit by a lightning strike, the induced static currents could be important enough to destroy the coils. In the resonance section of the antenna windings, those for medium and long wave are put in series, and the larger one is shorted when medium wave is selected. The corresponding windings in the oscillator section are arranged in series as well, but this time also with trimmer capacitors in between. This already makes the alignment between oscillator and antenna sections more difficult, but on top of that, one should notice that there are trimmers only in the oscillator section. In other words, one could try to align the radio for one band only and hope that the unit would receive decently also in the others. This is maybe the reason why, when the shortwave band is selected, the mixer tube is biased to ground, ignoring the AGC line. Finally, at least in this unit, the input voltage for 240 volts AC is fake, and the maximum voltage should be just 220 volts. Here is the data regarding the RF coils. The inductances have been measured, but the exact behavior of these coils depends also on the way they have been distributed and the effect of the connections in series already mentioned. This is the map of components under the chassis. Most of the space under the chassis is occupied by the band switch selector and by the power supply, and there was no tag strip for organizing the components. Ideally, rebuilding the circuit under the chassis, a tab board with eyelets could help resolve the issue. However, at least for now, a standard perforated board will be used. The components on the board will be those that appear here on a gray background, and the numbers framed in a light blue square correspond to the connections prepared on the board. However, the final electrical arrangement will include more amendments. There will be only one antenna input decoupled by a capacitor. The other antenna input will be used as a convenient ground point, which would allow the usage of a standard BNC adapter. The trimmer capacitors of the IF transformers will have additional capacitors in parallel so that they can be aligned to 460 kHz as they are supposed to be. A halogen light bulb will be put in series with the B+ line for preventing disasters in case of shorts. 4 halogen light bulbs will be put in parallel with themselves and in series with the mains. This will bring the AC input voltage down to a correct value, considering that nowadays the mains in Europe provides 230 volts. This would also reduce the initial current surges and major damages in case of other failures. 2 fuses will be inserted before the input power. They will be fast-blowing fuses rated only for 100 milliamps because the halogen light bulbs will prevent significant current surges, and these fuses will comfortably blow at about 800 milliamps. The chassis will be connected to the electrical external ground for obvious safety precaution, especially considering that it is exposed on the rear of the cabinet. Some decoupling capacitors will have their values increased, with the hope of reducing unwanted harmonics, while the value of the noise filter capacitor will have its value reduced for interfering as little as possible with the RCCB breaker switch. In the oscillator section, the coil for the long wave will be made independent from the medium wave one, and some capacitance will be added to the trimmers C23 and C26. The loudspeaker is extracted from the cabinet. The cone is in very good condition. The speaker coil scratches a little bit, but maybe it is just dust. The field coil is okay, but the primary winding of the output transformer is open. The output transformer needs to be inspected and may be replaced. Therefore, it is separated from the loudspeaker. Because there is the hope to clean the voice coil from dust without dismantling the loudspeaker, at the moment the basket is cleaned externally with the same gel rust remover already used for this project. It must be applied with a small paintbrush and removed with dry cotton balls as many times as necessary. When the result is satisfactory, some alcohol helps in removing all the residues. The space between the cone and the basket is cleaned using an air blower and a soft paint brush. With all the cleaning, Now also the voice coil is free from dust and it does not scratch anymore. However, for extra precaution, a signal is applied to the voice coil with the cone facing down to help expel more dust. This works relying on the residual magnetism of the pole piece because for now the field coil is not powered. At this point, it is a good idea to protect the cone with a piece of cardboard. It is now time to verify what happened to the output transformer. It seems only a bad contact, precisely at the most external end of the primary winding. However, before reaching the primary winding, it is necessary to unwind the secondary. The secondary winding had 64 turns. The outer end of the primary winding is reached. This is an extremely thin enameled wire, difficult even to solder. The loose end is reconnected. The thin wire of the primary winding was kept in place with wax. Now more wax is applied before putting new insulation. The primary winding seems okay now. The secondary winding is wound again on top using the old wire. However, the result is larger than the original because the turns are slightly spaced, and that requires adding an extra layer. Unfortunately, that is too much and the laminates do not fit. In the meantime, the cardboard that is keeping together the windings is falling apart. A replacement for the piece that would hold the ends of the secondary winding is fabricated out of the plastic of a small vegetable basket. Then, the secondary winding is unwound again. But this time, this is done by hand, also straightening the wire and leaving it on the floor. The same wire is used then again, but this time it is wound by hand, paying attention to keeping the turn as compact as possible. Unfortunately, the last turn does not fit, but 63 turns instead of 64 should be okay. Also, 3 laminations do not fit, but instead of forcing them inside the windings, with the guarantee of breaking the thin wire that makes the primary, it is better to not insist. The repaired output transformer is installed back on the loudspeaker. Then the impedance is measured at 1 kHz, without energizing the field coil. The result is a little high, but it should work. In the effort of opening the plug that is used to connect the loudspeaker to the chassis, a small piece of Bakelite is broken. It is repaired with superglue. The new wires are connected to the speaker, twisted together, and inserted into a fiberglass sleeve. The volume potentiometer also contains the power switch, which does not work. The switch is enclosed in a metal capsule. The metal lid must be removed in order to inspect the switch mechanism. There is no apparent damage, but one contact is not working. Some alcohol is used together with a toothbrush for cleaning the surfaces. Some Vaseline oil is applied using a thin paintbrush. Now that the switch seems to be okay, it is appropriate to consider possible safety issues. This pin engages with a corresponding socket in the switch mechanism, which is in contact with the mains. Between the pin and the potentiometer shaft there is only a small insulation bush. The plate that is used for closing the switch capsule has a hole through which the switch socket can be operated by the potentiometer pin. This socket is in contact with the mains, but between the socket and the plate there is insufficient clearance. It seems advisable to enlarge that space. It seems also a good idea to insulate the plate in case it were pressed over the switch mechanism. Here some Kapton tape is used for the purpose. The switch capsule is closed. Some attention is given also to the potentiometer section, applying some Vaseline oil. The component is reassembled and tested, verifying also the insulation between the switch terminals and the other metal parts that are exposed. At the moment there is some electrical leakage due to the fact that the alcohol used for cleaning contains some percentage of water, which has not evaporated yet. Rebuilding the circuit under the chassis starts from the direct connections to ground, followed by the components that from the tube sockets also go to ground. The connection for the tube filaments comes next. Here only one wire is used because all the tubes have one end of the filament to ground. The power transformer is installed on the chassis. Some cling film is used to protect the paint from scratches while still working on the chassis. In this radio, some wires are shielded using springs, which seem to be made of bronze. Before reinstalling them, some good cleaning is appropriate, and also for this occasion the gel already used in this project for removing rust and for cleaning contacts is applied. However, these springs also accumulated some other type of dirt, and a wire brush helps in the cleaning process. Anyhow, in the end they are washed and then dried, which is not visible in these clips. Considering that these springs are large enough for making sure to obtain a perfect result, some shielded audio cable is inserted. At this point, the power supply and the final audio amplifier are ready and can be tested. First, the power supply with only the rectifier tube. Then the audio inserting also the final amplifier tube. So far, so good. The electrical reconstruction proceeds Now up to the audio preamplifier. As already documented in the section dedicated to the schematic diagram, some components have been grouped together in a single board. This board is now going to be installed under the chassis. Also, the second IF transformer is installed, but before that it is wrapped in cling film for protecting it from scratches. For testing, the signal is injected to the grid of the detector preamplifier tube, and now the full audio frequency section is OK. Until now, the band selector switch has been set aside, with old components and wires still attached to it, with the purpose of allowing possible revisions of the reverse engineered drawings for as long as possible. It is now time to remove all this and to clean it so that it can return in its place under the chassis with new wiring. When all the excesses of solder are removed, it is possible to clean the switch with a soapy oven degreaser and a soft toothbrush. Then, the switch is washed with water and dish soap, and finally dried with an air blower. This switch has a defect. While rotating clockwise, it does not stop turning. However, that would be just a small issue because the band selection would work anyway. Therefore, it is judged safer to just keep it as it is. This is a standard 9-pole, 4-throw switch, and quite a few of the terminals are not used in this radio. For reducing the risk of making mistakes, it seems a good idea to insulate these unused terminals to avoid the chance to solder on them. For the purpose, some heat shrink pipe is used. Finally, Vaseline oil is applied to the contacts using a thin paint brush. It is now possible to rebuild the RF section, keeping in mind the space that will be occupied by the band selector switch. After also the first IF transformer is in place, the RF coils for long and medium wave can be reinstalled. The band switch is installed. It already has a couple of wires attached to it because they are connected to a location that would be particularly difficult to reach once the switch is in its final place. The capacitor C17 was originally a paper cap. It is connected between the oscillator grid and the variable capacitor with the oscillator coils, therefore it is replaced with an NP0 style capacitor. Being a surface mount component, it is adapted by adding terminals. The variable capacitor needs to sit on grommets, and new ones are inserted in the corresponding holes on the chassis. For the purpose, the board that was made for this restoration must be temporarily moved aside. 3 decoupling capacitors that do not appear in these clips will later be removed from the added board and connected closer to the coils and tube socket. The shortwave coils are the last things to add because they are located above everything else. As already mentioned in the section dedicated to the schematic diagram, the antenna connection is arranged in a slightly different way compared to the original, which will allow the use of a B and C adapter later. The continuity of the filament in the tube type H4129D or RENS 1294 is intermittent. An attempt to desolder the pins so that the base could be extracted and inspected fails. Therefore, the pins are just resoldered. Luckily, this worked well. Later, after having tested the tube in circuit, verifying that it functions correctly, the loose base and the top cap are glued to the glass envelope using super glue. The replacement for the missing tube type, the K2, arrives, and the top cap is connected to the variable capacitor on the antenna section. It is now possible to test if everything done so far is correct. And yes, without any kind of alignment, one station can be received in the medium wave band. For the alignment of the IF transformers, this temporary adaptation is made to the audio section in order to read the AGC negative voltage without interfering too much with it. The signal at 460 kHz is injected initially at the first grid of the IF amplifier tube, reading the AGC negative voltage with an oscilloscope configured for DC input, tuning only the second IF transformer. Unfortunately, as expected based on the calculations, it is impossible to obtain the resonance at 460 kHz, and it is necessary to add capacitance in parallel to the original trimmers. The IF transformers were already modified for the purpose, so that now it is not necessary to open the cans. The added components are NP0 capacitors, and their final value is determined experimentally. The signal at 460 kHz is then injected to the grid of the tube type K2, so that also the first IF transformer can be aligned. However, also in this case, it is necessary to add capacitors in parallel. While injecting the signal at the grid of the tube type K2, it is observed the influence that the antenna tuning has, noticing that there is an internal oscillation if the variable capacitor is fully meshed and the medium wave band is selected. Therefore, during the alignment of the IF transformers, because the band selector is set to medium wave, the variable capacitor is partly open. At the end of this phase of alignment, injecting a sweeping signal between 450 and 470 kHz. This is the result that can be seen on the oscilloscope, keeping in mind that the peak is the most negative value. Just for the record, it was impossible to obtain a perfectly symmetrical bell curve. The RF section shows strange behaviors, very likely due to parasitic oscillations, more or less associated to the main oscillator frequency. They can be harmonics or a copy of the main frequency, but slightly shifted. That may be the result of the rearrangement of the ground connections, the lengths and the path of the wires, the fact that there are no more paper capacitors, the relocation of some components, or maybe that was in part also an original design flaw. Anyhow, for trying to mitigate the issue, the wires are shortened where possible. The value of C15, C18, and C19 is increased, also replacing them with film capacitors. The connections to the variable capacitor, as well as to the antenna socket, are replaced with our G174 coaxial cables. The top cap of the K2 is connected using our G58. The tubes that are supposed to be shielded are wrapped around kitchen aluminum foil, and some thin metal sheet is prepared for isolating the RF section. For installing the shield, allowing it to be also removable, it is necessary to solder a few short brass standoffs on the chassis. Then, a piece of cardboard is used to find a suitable shape for the shield so that it could fit properly. The shape is copied on a thin iron sheet and then cut out with the help of scissors. The flaps on which the shield is meant to sit are perforated using the drill, but off camera. The shield is then installed on the standoffs previously soldered on the chassis. There is another space that may be divided with a shield. Therefore, another shape is cut out and then installed. Before soldering the standoff, a stainless steel screw is inserted so that the solder does not fill the cavity. Finally, also the bottom of the chassis is shielded using a large sheet of thin iron recovered from a 5-liter cooking oil can. However, it is necessary to prepare some insulation in the area above the RF section to avoid shorts. There is a space under the chassis in the power supply area where maybe there was originally a filter capacitor of an unknown shape. In this area, a small plastic box hosting 2 fuse holders and 4 halogen light bulbs is going to be installed. There are already 3 holes on the side that will be used for fixing the box. While the function of the fuses is obvious, the purpose of the halogen light bulbs is to operate like a ballast for dropping some of the input voltage, for controlling current surges, and for preventing major damages in case of component failures. The screws that will be holding the box on the side of the chassis are glued first, using superglue and baking soda. The fuse holders are installed next. Superglue is applied for them as well, for making sure that they will not turn while inserting or removing the fuses. A 3-prong power cord is inserted in the box and connected to the fuse holders. Extension wires are connected to the ground line and to the output of the fuse related to the supposed neutral line. The output of the other fuse will be connected to the halogen light bulb array. Four sockets for halogen light bulbs are installed on the lid of the box away from the space occupied by the fuse holders. These sockets will be connected together in parallel. One side of this array is connected to the fuse, while the other is attached to an extension wire that will join the other two. The 3 extension wires coming out from the box are twisted together. The box is fixed on the side of the chassis. The fuses are inserted in their holders. They are rated 100 milliamps fast blow, but because current surges are controlled by the light bulb array, they will be able to stand the current normally absorbed by this radio, about 250 milliamps. The extension wires are connected to the power transformer and to the power switch. The yellow ground wire is marked to distinguish it from the tube filament power line and connected to the chassis. Another halogen light bulb is going to be installed. It will be inserted in series with the B+ line, for preventing major damages in case of short of the filter capacitors or other components connected to it. All the halogen light bulbs inserted are rated for 230 volts 40 watts. The variable capacitor of this radio is driven by a fairly sophisticated dial mechanism attached to the dial panel. The dial pointer is held in place by tiny screws that have yet to be identified. Using a thin paintbrush, Vaseline oil is applied to all the screws to allow their extraction. When the dial pointer is successfully removed, it is possible to separate the dial panel from the mechanism. This dial panel was made for hosting two pilot lights, but one of them is missing with the whole socket. Unfortunately, the socket was made specifically for this type of panel, and the replacement for the missing one will have to be adapted. An attempt is made to do some cleaning on the dial mechanism using alcohol and even acetone, but without any visible result. Therefore, the dial panel and the mechanism are submerged in the liquid rust remover already used in this project. Only 1 hour later everything is much cleaner, the traces of rust are gone, and it is possible to remove the remaining stubborn dirt with the help of a soft wire brush. Now it is possible to recognize that some parts of the mechanism are made of stainless steel and that the dial panel is made of aluminum. After washing the parts with water and dish soap, it is possible to further dismantle the mechanism. The bracket and the panel need to be painted, in particular the first one with zinc paint, for preventing the development of more rust. Therefore, they are prepared by drying them and using masking tape where necessary. In the meantime, also, the remaining parts of the dial mechanism are submerged in the rust remover product for the sole purpose of cleaning them. They are also extracted just 1 hour later. panel and the bracket have been painted, and now it is possible to rebuild the dial mechanism. The 3 friction gears must be meshed together. In order to do so, it is necessary to use a precision knife. Vaseline grease is applied where necessary. This set screw is the one that will keep in position the dial indicator shaft. The dial indicator can be installed only when the whole panel and mechanism is placed on the chassis and connected to the variable capacitor. For now, the indicator is prepared with some Teflon tubing in place of the original white painting. First, the band indicator must be inserted on the band selector shaft. The dial comes next. The variable capacitor and the dial mechanism should be aligned, then the flexible shaft coupler is connected to the dial mechanism and the variable capacitor. When this is done, it is necessary to verify that the variable capacitor can travel all the way from its minimum to its maximum capacity, being properly stopped by the dial mechanism at the two ends. When the dial is set to one of the two ends indifferently, the dial pointer can be inserted vertically and fixed with its set screw. The dial glass is installed temporarily to verify that the dial pointer does not brush on it. One should not forget the dial lights. For the aesthetics, the pair of wires is covered by a fiberglass sleeve. A replacement for the missing socket is used on the second light. A piece of Heath shrink pipe is inserted to keep the socket in place. There are very few adjustments for the RF alignment of this radio model, and exclusively in the oscillator section. Two of them are available from above the chassis, on top of the corresponding oscillator coil can, while one is accessible only from under the chassis. It is interesting to observe that the adjustments are available only for the medium wave and long wave bands. Here is where they are located in the schematic diagram. In both the antenna and oscillator sections, the resonant coils for medium wave and long wave are in series. When the medium wave band is selected, the coils for the long wave band are shorted. Under the circumstances, the trimmer capacitor C25 is suitable only for the adjustment of the medium wave band, while the trimmers C23 and C26 are useful for the long wave band. However, the trimmer C25 can be adjusted for the medium wave band independently from the long wave, but the trimmers C23 and C26 for the long wave band depend also on the adjustment of C25. Therefore, it is reasonable to assume that the medium wave band should be adjusted first, followed by the long wave band, but in this case without touching the trimmer C25. This is all good, but in the item under restoration, it is impossible to align the medium wave and the long wave bands according to the dial scale. In order to read the signal generated by the local oscillator, it is possible to loosely couple the oscilloscope probe to the connection of the small oscillator plate, here represented as one of the grids inside the tuba K2. Here it is visible the probe hooked to the insulation of the wire. In the shortwave band, there is nothing strange in the oscillation, and in fact, This is the band where the radio operates correctly. In the medium wave band, with the variable capacitor fully meshed, the oscillation is problematic. A portion of the main oscillation is shifted, creating this ascending ladder effect. By rotating the capacitor so that the capacitance progressively decreases, the ladder effect becomes descending. At a certain point, the ladder effect disappears and the oscillation on the higher side of the band becomes clean. In the long wave band, the oscillation is similar to the one read in the medium wave band, with the difference that the frequency is too high for the band and that the oscillation never becomes clean. Various experiments have been made, in particular around the capacitor C17. Changing values, inserting a resistor in series or in parallel, even replacing the component with the original paper capacitor, but nothing showed a noticeable improvement. Therefore, something more drastic was considered, separating the coils for medium and long wave like this schematic diagram shows. Subsequently, the alignment for the medium wave band was performed with the variable capacitor fully meshed, looking for obtaining a less pronounced ladder shape, which would not change phase while increasing the frequency. As for the long wave band, the alignment was performed seeking at least something that would contain some component of a frequency in the right interval, even though it was inevitable the presence of other higher frequency impulses. Considering that now the long wave band coil is no longer in series with the medium wave one, the values for the trimmers C26 and C23 also had to be increased by adding small fixed NP0 capacitors. The result of this adaptation and alignment is that in the long wave band the oscillator would operate about between 650 and 800 kHz, which with the intermediate frequency at 460 kHz would theoretically allow the reception between 190 and 340 kHz. As for the medium wave band, the oscillator interval would be about between 1500 and 2000 kHz, which could allow the reception between 1040 and 1540 kHz. This would cover only a half of the typical medium wave band, but at least this way it works. It seems important to clarify that it was judged safer to leave the antenna section unchanged because, at least based on calculations, the separation of the long wave resonant coil from the medium wave one would not have given any improvement. This test was done in the evening, starting with the long wave band. It is still difficult, the reception in the lower band, but at least there is something. In the distance there is a thunderstorm, and that is the reason for the noise of electrical discharges.
Это день практики, это дорога, транспорт, любой управление транспортом. आज नवरात्रि का तीसरा दिन है। तीसरे दिन माँ चंद्रघंटा को पूजा जाता है। इस दिन माँ को मारू से बनी मिठाई का भोग लगाया जाता है।
Дело в том, что уже давно, последний, наверное, год-два, представители крупного săptămâni în satul anul Ardeal și îmi luase opera lui Schopenhauer. Качеството скрипът и на ден по една стъпначка.
Establishment of Talk Company. Talk, an acronym for
Problema este lipsa de echipament de protecție, problema este legată de nerespectarea regulilor de
Under the circumstances of this radio, the dial scale cannot be helpful in determining the received frequency. This includes by design also the shortwave band, which came with no provision for an alignment. It seems appropriate to an RF buffer to this unit so that an external counter could show the received frequency by subtracting 460 kHz. The same circuit already used in previous projects is planned, with only an adaptation necessary for the lower power source voltage. In this case, a Schottky rectifier and a regular fuse are preferred. The board containing the RF buffer is hidden in a small box that will be fixed above the chassis using a small bracket, which will be hooked to two holes already available and not used. The speaker panel is separated from the cabinet by removing 6 screws. The grill cloth was just glued, and it is easily removed. The speaker grill is made of 3 pieces of wood with a darker color compared to the rest of the cabinet, and they should be removed, but that is easier said than done, because the screws that hold them are rusted and stuck. However, after some careful work eventually, they are removed successfully without damaging them nor the cabinet. The wood used for the walls of the cabinet is very thin. Nevertheless, the front panel is held to the bottom, mostly by 2 small metal brackets fixed with tiny screws. This does not seem sufficient, considering that the chassis is very heavy and they are removed. In place of these small brackets, a couple of suitable wood blocks will be glued. The wood veneer needs to be re-glued on some part of the cabinet, especially on the top. A syringe with proper needle tip is used for injecting wood glue deep under this large area. It takes some time and patience to reach with glue all the space underneath the veneer. When it seems enough, the surface is cleaned from excesses of glue with a wet sponge. The surface must be pressed with the help of a piece of wood and clamps. However, to avoid getting this piece of wood glued together with the veneer, some cling film is put in between. While it takes some time before the glue under the veneer is cured, also other parts of the structure are re-glued and clamped. Compared to the weight of the chassis, the structure of the cabinet seems too fragile, and some wood blocks are added in every corner that would not create an obstacle to the chassis. These triangular pieces of hardwood were recovered from a vegetable box. They are just perfect for being used as wood blocks. The bottom of the cabinet has a large crack that can be repaired only with a patch made of a thin piece of wood attached from outside, because inside the cabinet the space is occupied completely by the chassis. Also, this thin wood patch comes from a former vegetable box. As already mentioned, instead of the two small brackets screwed between the front panel and the bottom, some small wood blocks are glued. Here are all the wood blocks that have been added. When all the work on the structure has been done, acetone and extra fine steel wool balls are used to remove the old lacquer. The purpose is not necessarily to strip the wood completely, but just up to the point where it is possible to stain it again and apply new lacquer. In retrospect, considering the stickiness of the original lacquer, while diluted with acetone that must have been shellac and maybe just using denatured alcohol, would have made the job easier. Anyhow, applying acetone several times worked well anyway. There are a couple of places where the veneer is missing. Some wood filler is used to cover them. The original wood has a nice uniform color. Only some isolated areas need to be much darker. Therefore, some masking tape is used to isolate those areas, and the wood stain is applied where needed. Then some red oil is applied to all the surfaces, including under and inside the cabinet. Finally, the excesses are removed with a soft rug, and all the parts are sprayed with an opaque acrylic paint. The original grill cloth was washed, but in the washing machine. The result was awful, but it helped to understand what was the original pattern. It is now time to rebuild the speaker grill. New screws are used, making sure that they have the correct length. Under the circumstances, it is necessary to find the original holes in the grill pieces, and a little trick with small screwdrivers helps in doing that. A contact adhesive is applied for attaching the speaker cloth to the grill. This is the closest pattern that was possible to find in a local haberdashery shop, only available in this red color. But it will be okay. This is the condition of the dial scale printed on the original glass, unfortunately completely unrecoverable. Luckily, on Docty SF plenty of pictures of this radio model are available, some of which show the dial scale. With a little bit of luck, it was possible to enlarge and stretch those pictures enough to allow a redraw of the scale. With a lot of patience and the help of Xfig, a very old but still very effective vector graphics editor, the dial scale was redrawn. The original glass has a particular shape made on purpose for guiding the light from above the glass. With the plan of getting the glass reprinted with the new drawing, the old residues of the scale were removed using various detergents, cotton balls, and also extra fine steel wool. But it turned out that printing on glass can be unsafe for the printer heads, which may be damaged by the radiations used for melting the ink because of the good reflection of the glass. Therefore, it was proposed to experiment with an adhesive transfer method, although there was the obstacle of very fine printings and, in this case, also the necessity of putting the scale on the front of the glass instead of the back because the ink needed an extra layer of white super sticky background. The experiment failed, but it is shown here so that also others could understand the drawbacks of this type of approach. It was recommended to leave it resting for 24 hours before removing the transparent foil on top. It is unclear if also pressing it was a good idea or a bad one. The next day the foil on top was removed, but some of the extra sticky adhesive remained on the glass. Having accepted the failure, an attempt is made to remove the residues of adhesive without wiping the printing using Vaseline oil. This cleaning worked, but the final result was not very satisfactory anyway, because of the extra fine writings that did not transfer well with this adhesive printing method. Therefore, some transparent polycarbonate was ordered to allow a proper printing on it. It would not have the special 45 degrees edge on top for directing the light, but a thought will be given to this issue later. The polycarbonate glass was printed, and it is now possible to install it. The film on the front is not removed completely for protecting the surface until the reveal. A small piece of aluminum foil is put above the dial glass to help in directing the light on top of the glass. This is done because the new glass does not have the 45-degree edge. Some Kapton tape is used for holding the aluminum foil in place. The old glass is kept anyway. It is protected with cling film and inserted in an envelope, which is then attached inside the cabinet on one side. Considering the weight of the glass that it contains, to make sure that the envelope does not come off, 4 tiny screws are used at the corners. It is time to install the loudspeaker on the speaker panel. The cardboard that was used for protecting the cone while working on the chassis is now removed. However, the speaker had a small tear that now must be repaired. The glue that is applied will remain elastic also when it is cured. On top, a patch made of a small piece of T-bed is attached. At this point, it becomes apparent that the original holes on the speaker panel made for holding the loudspeaker do not correspond exactly with those on the speaker basket. In fact, the original screws were relatively thin compared to the holes on the wood and installed slightly tilted. Instead of enlarging the original holes, the loudspeaker is oriented in a way that allows using just wood screws. Finally, the speaker panel is ready and it can be installed in the cabinet. Before getting in the cabinet, here is a last view under the chassis. The bottom metal sheet is temporarily attached only using some adhesive tape. It will be fixed better when also the chassis will be held in the cabinet using screws. The cling film used for protecting the parts from scratches can now be removed. And here is the final view above the chassis. The chassis gets in the cabinet. The chassis and the additional metal sheet at the bottom are fixed to the cabinet using screws. The loudspeaker and the field coil are connected to the chassis. The IF amplifier tube requires an extra shield on the top. The tube shielding, including this particular cap, must not get in contact with other metal parts in the radio because they are connected to the cathode of the tube and not to ground. The masking tape used during the restoration for avoiding electrocution around the loudspeaker contacts can now be removed. The radio arrived without a back panel, even though there are signs suggesting that originally there was one. Unfortunately, online there are only a couple of pictures of this radio with a back panel. This one comes from DocTSF. But this does not seem to be the original panel, and consequently we don't know how it was actually shaped. For this restoration, a thin metal net is used in place of a traditional panel. The net is cut to the right size, but at the bottom, for preventing injuries, the net is folded instead. For holding the net on the back of the cabinet, thin wood screws will be used. However, the net is not strong enough, and it is necessary to solder some brass washers where each screw is going to be placed. The radio arrived with the original power plug, which is not used in this restoration, but it is nice to keep it with the unit anyway, making sure that it would not get loose. Before putting the metal net on the back of the cabinet, it is a good idea to connect an extension for the signal that might be used for a radio frequency counter. The connections for the antenna were swapped during the restoration, so that now a standard coaxial adapter can fit. The dial frame is now installed on the front panel using new but period-appropriate screws. The temporary knobs are removed because it is time to put the original ones. 3 felt washers are made and put on the shafts before installing the knobs. These are the parts that have been discarded during the restoration. The old components will be kept at least for a while, but not associated with the original unit anymore. Therefore, a drawing of the labels of the components is made and kept with the documentation of this restoration. Oddly enough, until the end it was not noticed that the cabinet was slanted. Here, the cabinet squareness is compared to that of a book. The book is touching the cabinet, but at the base there is a significant gap between the two. There is nothing to do about it, and it is not noticeable in real life. However, on camera that slantedness is very visible. So be prepared for the reveal. The test is done in the evening using only an indoor loop antenna, and it starts from the long wave band. The frequency counter on top is a prototype built for allowing the division of the input signal received from the radio local oscillator. Then, the frequency counter will subtract 460 kHz for showing the supposed received frequency. For the long wave band, initially the input frequency must be divided by 3, then it is divided by 2 for obtaining a reasonable reading. The issue is described in a previous part of this video about the RF section of this radio. However, here the radio also receives stations from the medium wave band. Moreover, in all bands there are images, and that is okay under the circumstances. Anyhow, the unit receives, and that is good.
che noi possiamo ritrovare.
At this point, the reading on the frequency counter is wrong, and it must be set for dividing the frequency by 2 instead of 3.
El central izquierdo, John Murciano, que se coloca en lugar de central izquierdo. Ahí está, quería meter.
Medium wave band. The frequency counter must be set for normal reading without prior division of the input.
Нет, потому что они очень выгодны, они очень маржинальны в производстве для
Juega la bola Dani Olmo, que le vemos en una posición, se abre algo retrasado.
Quindi maneggiavo il bollettino regionale e gli dicevo, non mi ero mai accorto, eppure nel 94 ero sindaco, non mi ero mai accorto dell'effettiva vitalità di questa legge e del fatto.
Shortwave band.
lange Spiel gezogen haben. Verehrte Zuhörer, dann werden Sie vielleicht auch, liebe Kerle, ja, mitfühlen.
Dann sehen wir wieder.
Kapıyı bakıyor. Elde etmemeye çalışsam da hoşlanmıştım. Birlikte geçirdiğimiz iki aime la on l'appelle ça comment? La démocratie participative.
Compagnie, applicazione Triale. Io ne proviamo un po' di quello.
Montre est envahi par de prince, à n'importe qui.
Я тоже кое-что знаю о китайской лапше. Я пробовал самые разные ментяо. Например, пекинскую лапшу с соусом из всего.
L'idée, le résultat et la qualité de la participation de Aviscat automatically valid to keep Buenos Aires Nevada.
Şimdi soru su üzerine böyle bir şey yanlış olur, ayıp olur da şöyle.
Anche Paragon. Poručím svého
Répond au potentiel acheteur.
un développement sans critique.
Van publikozni a vízzel, ha mindenütt bevonta a húst.相信各位朋友都聽過董小宛。心愛當然係悲痛。Hacia abajo y sigue estirando la ojo.